Okay, we're looking at the work kinetic energy theorem. The external work is equal to the change in kinetic energy. And remember that kinetic energy is equal to 1/2 mv squared. As in previous examples, the best way to get the most out of these problems is when I ask you a question or when I ask you to calculate something, is to try it yourself first. After giving it a good effort, then see what I do as an answer. As we see here, once again we're doing the block on an incline, and our question is, once the block reaches the bottom of the incline, after moving distance d, what is its final kinetic energy? In this case, the block is the system. There is no friction. Calculate the work done by gravity. Okay, that work is the integral from xi to xf, f sub g sine theta, that is the component of force in the direction of displacement, I hat, dotted to dx I hat. Fg is equal to mg, the force of gravity. We go ahead and integrate it, and we get the term down here between the limits of xi and xf, and we get Fg sine theta d. Note that this is the component in the direction of the displacement d. So, all right. What is the change in kinetic energy? Well, we've calculated the work to be 63 joules. So what is the change in kinetic energy? Once again, that is 63 joules is the change in kinetic energy. Whatever the work is, as shown up here, okay, whatever the work is, work external is equal to the change in kinetic energy. How is the change in kinetic energy related to the initial and final velocities? Okay. The change in kinetic energy is defined as the final kinetic energy minus the initial kinetic energy. We can write this in terms of velocity, which will be 1/2 mv final squared minus 1/2 mv initial squared. What is the final velocity? Well, we're given that the initial velocity, vi, is equal to 0. And so we can solve, because we know what delta K is. Delta K is 63 joules. So we now have that 63 joules, okay, is equal to the change in kinetic energy. So 63 joules is going to be equal to this 1/2 mv final squared minus 1/2 v initial squared. That's 0. And we can solve for the final velocity squared. And that's 5.02 meters per second. End of problem.